for this video is independent and dependent events. And the biggest difference between exclusive and inclusive events and independent and dependent events is now I'm looking at two different things happening. So when we talked about inclusive and exclusive, I was talking about drawing only one card out of a deck and what the chances were of it being red or a king. In this case, I'm not just drawing one card out of the deck. I'm going to draw one card and draw a second card. And we're going to look at how those two things relate to each other and how they affect each other. Independent events, in this case, the first event happening is not going to affect the probability of the second event happening. And we're going to look at an example of what this means and then figure out the equation that goes with it. So if I talk about, I'm going to roll a die and flip a coin. What I've given you here in your guided notes that are on the Math 2 page on my website, I've given you an option for your sample space. What I'm going to do is this sample space would be flipping ahead and getting 1 on the die. So I'm going to continue filling this out so that we can look at our sample space. And each of these is a different outcome based on what happened when I rolled the die and I flipped the coin. So you can see here, there are 12 different options in my sample space. And I'm going to be flipping back and forth between this slide and the next slide with some examples that we're going to look at. So the probability of rolling a 3, if I look at my table, there were 2 pieces in my sample space where I rolled a 3 out of the 12 total, so that would be 2 out of 12, which is going to simplify to 1 out of 6. And if I look at the probability of getting a tail, there are 6 outcomes where I have tails out of the 12, so that's 6 out of 12, or 1/2. Question 3, though, is asking us about getting a 3 and a tails. And there is only one spot that we have both things happening. So this would be 1 out of 12. If you look at part 1 and part 2, you should be able to quickly determine how I could use the probability of rolling a 3 and the probability of getting a tail to figure out the probability of getting a 3 and a tail. And the answer is multiplication. So if they are independent, and I'll make this a little bit bigger so you can see better on the video. If they are independent, I'm going to take the probability of event A and the probability of event B and multiply them. But I could potentially have 2 events where one affects the other. And that is a dependent event. And we're going to look at the definition and the calculations and some examples together to figure out what's happening here. So calculation-wise, we're going to figure out what this means as we do an example, but we're looking at what's the probability of B happening after A has already occurred. And we're going to figure out how to do that mathematically speaking. So let's look at our first couple examples. What I want to do right now is just go through the list and see at home if you can figure out which ones of these are independent and dependent, and then hit play and check in and see how you did. So selecting a marble from a container and a jack from a deck of cards. If I have a container of marbles over here and a deck of cards over here, does anything that I pull out of this, the container of marbles, have any effect on what I pull out of the deck of cards? It doesn't. So that would be an independent scenario. A number less than 4 on one die, and a number that is even on another die. even if I was using one die, every time I roll, because it's just a standard die, it's not been manipulated in any way, every time I roll, that doesn't affect what happens on the next roll or what happened right before it. There's no correlation between those two. They don't affect each other. So this is another independent scenario. Now in part C, I have a deck of cards. I'm going to pull out a jack. But instead of putting it back in the deck, I have taken that jack and put it aside. Because I put the jack aside, I have automatically changed the deck of cards, and it's not a standard deck anymore, because now instead of having 52 cards, I have 51. So this is dependent, because by putting that card to the side, I've completely changed what's happening in the standard deck. It's not standard anymore. Part D, winning a hockey game and scoring a goal. In order to win a game, you have to score a goal. So that's going to be a dependent scenario as well. So we're going to kind of use what we just walked through here to figure out some example problems together. And we're going to do this example, which is on your printout of your guided notes that I gave you. So there's a box that has 4 marbles that are red and 6 marbles that are purple, and our goal is to choose 3 marbles without replacement. Because I'm not putting the marble back in, I am changing that initial box of marbles, so this scenario is dependent automatically. So what I'm going to do, I already kind of wrote out my formula for you. I'm going to do the probability of drawing a purple the first time, multiplied by the probability of drawing a purple marble the second time, multiplied by the probability of drawing a marble that is red on the third time. So the first purple marble, well, I have 6 purple marbles to choose from. There's 10 marbles in the bag altogether. So the first purple marble would be 6 out of 10. The second purple marble, because I know that I've taken the marble and put it to the side, that's automatically going to change the number of marbles in the bag to 9. And because the first one I drew out was purple, and I set it to the side, now in the bag of marbles, I only have 5 purple marbles to choose from. But for this last fraction, because I have not drawn out a red marble yet, I'm going to still have all 4 red marbles in the bag. So they're all still up for grabs. And because I've taken that second purple marble and set it aside, I've now dropped down the number of marbles in the box to 8. And if you multiply this out all together, it's simplified to give us 1/6. The other questions on the guided notes are, I'm going to let you try at home. Make sure that you work through those. There is a question about Shield High School. There is a question about drawing 2 red cards without replacement. And there is a card being chosen at random and finding the probability of them both being 7s. Those 3 questions I want you to try without me. Bring them to class tomorrow. That's the first thing we're going to look at together. If you have any questions, as always, make a note in your notebook. Make sure you ask me at the beginning of class. We'll talk about this together and go on with these examples that you're trying at home.